Hello, this is Wes at Bad Seed Games, and we're going to be picking up where we left off. Now, when we left off, we had basically set up the animation and the calculation of damage on the player object. But before we get too far into this, the first thing that I want to address is the fact that this is terribly expensive for the processor. Not necessarily to the point where one or two enemies is going to clog the system, but as has been brought up to me by a member on the Playmaker forums, the raycasts that we have both in the lookat and the raycast, they are actually rather processor intensive. So what I'd like to go through is a way to optimize it so that you can add in a global shutoff switch, so that if the player is too far away, it's just going to disable it so that you don't have to worry about it running so many processes all at once. So let's get started. And now the first thing we need to do is we need to add in a finite state machine, yet another one, that will basically be our global shutoff switch. So now this one is actually really simple to set up. It's a simple two-state. And let's get the events started. So one for shut off and one for turn on. Now we want these, doesn't necessarily matter which one it starts in, but let's have this one as the on and this one as the off. Alright, so two simple transitions. If it's on, the action to turn off is what you're going to be calling. So let's get this set up. Now for the most part these are virtually identical, but before we get too far, let's set up the conditionals. Let's set up the system so that it will calculate the distance. And for that we're going to need a get distance. So you can find this in the game object subsection. It's going to be for the owner and the target. And we're going to store the result. We're going to need two variables. First is going to be distance and the threshold. They're both floats, so that's good. Let's store that one in the distance, and then we're going to do a float compare, because we're going to be comparing these two floats. So distance and threshold. Now before we get too far, let's give threshold a value, just so that it has something in there. 25 is a decent number. Now if it's on, the condition is that if the threshold is greater than the distance, if the distance is greater than the threshold, then that means that we're going to use the greater than, and then go to the shut off. Let's copy these two actions and paste them right here. And instead of the greater than, let's use the less than. Alright, so let's do a quickie test to see that it's firing correctly. And something's not happening. Oh, I know what it is. Because float compare has an every frame. We have it set to action only once. So it's only going to fire off once in these. We need to fire it off every frame. Or basically every frame. And as you can see here, it's now triggering. Alright, now what are we going to do with this? Well, for starters, we're going to tell it to send an event to all the systems that it's going to be controlling. But before that, we have to set up the conditions. So in the orientation, let's add global events. So this one's going to be disable and enable. And we're going to have to make sure that they are globals, because they are going to be called from something other than this finite state machine. And this is actually really simple to set up. So off. Let's add a global transition, disable. And for this one, let's add a global transition of enable. That's pretty much as easy as it is. So let's go ahead and do that for the rest of them. So add a new state, enable, disable, and off. And the last one in the angle detector. disable and enable. Okay, so basically now that we've got that set up, we have a empty state that's just going to do absolutely nothing. This will free up system processor cycles. But now that we've got these three states, these three finite state machines set up so that they all have a kill switch, now we have to tell it what to do. So in the on state, we're going to add 3 send events. 2, 3, and we're going to make sure that they're at the very top. Okay. And since we are accessing a finite state machine that's on the self, well, we're not accessing the self. We're going to be accessing another game object, but we're going to be accessing a game object's finite state machine in each of these. We can keep it as the use owner. Now we pull it down, so orientation, rangefinder, and angle detector. And the event is pretty simple. In the on state, we want it to be enabled. And we are not going to be doing these every frame because we don't actually need them to fire every frame. We just need them to fire once, and that's why they're all at the top of the stack. So let's collapse those so it's easier to select. Just copy them over, paste them in, and flip it from enable to disable. Alright, so let's take a look and see how that fares. Alright, so first we're going to check is the orientation. We're too far away, so it's off. Now that we're within the right distance, it's on. Okay, so let's take a look at the rangefinder, make sure that that's firing correctly. Disabled, enabled, okay, and the angle detector. Disabled, enabled. Now, this particular situation is a little hacky in a sense, because there are many ways that you can set up an artificial intelligence system that is much less of a drain on the system processor. But again, if you do want to use the raycasts, like I've been told, they are rather processor intensive. So any cycles that you can free up, the better. This will basically help with the user and the end user's experience, because then that means that less chance of it getting laggy. And it will also help because, say for example, most people don't usually have small little arenas like that. Usually they'll have vast levels. And you don't necessarily, if you have, for example, say 50, 60 to 100 enemies all there waiting to be triggered, you don't necessarily want to have absolutely everything on screen working right then and there, because that's going to be a huge drain on the processor. And this is a simple and easy way that you can set it up so that if they're not within range, just completely ignore them. Okay, so in the next video we're going to be setting up the next step, which is random walking, and the one after that will be patrolling via waypoints. But until then, I hope you've enjoyed this video, and if you like this video, feel free to comment, rate, and subscribe. Have a good one.